Alright guys, thanks for checking out this video. I'm going to get into a little bit of experimentation here. There are tons and tons of videos on YouTube where people are trying to make a portable generator quieter, and they're building a box and they're doing all kinds of things, but typically you don't see a real dramatic improvement in noise reduction. And I think a lot of what people are trying to do maybe just isn't quite the right approach. People don't necessarily understand what they're trying to reduce. Sound has a pretty broad spectrum, and if somebody's using a hard material or a soft material, it will have different effects on that noise spectrum. The softer materials are really good at attenuating higher frequencies. Heavier, harder materials with a lot of mass are really good at attenuating low frequencies. And a lot of the designs that I see out there really don't go far enough to address the key components of the noise that a generator would be producing. So I'm going to try and deconstruct this generator hush box a little bit, and it's going to start with really looking into how a small inverter generator like this actually works to begin with, because you'll notice that it's already enclosed. The engine is enclosed inside of a box, and it does have some noise mitigation already there, but of course there's always room for improvement. So I'm gonna dive in here and we'll take a look as to really what we're dealing with first of all, and then we can begin to select materials and perhaps a design that's going to be more effective than what you've traditionally seen. Alright, so I've removed the side panels and the back panel from the generator, and like I'd mentioned previously, this generator design is basically an engine that is already designed into a box, and that box does provide some sound deadening qualities, but not too much. As you can see from this side, sorry about that, you can't see any part of the metallic engine block anywhere. It's entirely enclosed in, it's like a plastic casing. And the way these generators actually work is the aluminum block for the engine, the flywheel, all of the moving components, all the metal components are actually encased in a plastic housing that provides an air gap. And air from the flywheel fan is actually drawn from the front of the generator, and it's pushed across all of the engine surfaces, and it's exhausted through the back opening here. And you'll notice there's an air gap that is entirely around the muffler here, so that air that's being drawn in from the front, it's cooling the engine block, and it's actually passing across the muffler and then exiting out the back grille here. So there is actually a mating ring on the back grille that seals with this rubber boot. So any of the hot engine air or the hot gases from the muffler are entirely directed out of the engine enclosure. So we're not trying to take air from around the entire generator and exhaust it out of the hush box. We only have to deal with the air that's basically coming out of this rear grille here. So that makes things a lot easier, and this is not too different from some higher end generators that you might see out there, like inverter generators made by Honda or similar. They use the same principle where they have a casing around the engine block, and air is used to cool the engine through that casing, and it's exhausted right out the back. So you don't have to worry about high temperatures within the generator case. You're just dealing with high temperatures directly around the engine itself. So that's that's, I think, an important point to make about trying to make a generator hush box is you want something that's going to have controlled airflow. An open frame generator is not going to have that controlled airflow because, well, it's just open. There is no casing around the engine or the flywheel or the generator itself, so you're not going to be able to control airflow. All right, so to start off with our hush box design, it's really not going to be much different than any other video you've seen on YouTube. People go out, they'll grab a box, and then they're going to start to line it with some rigid foam or some kind of foam board. But what we're going to do is a little bit different here. We're going to use a multi-layer approach. We're going to use some denser materials to try and attenuate the low frequency. We're going to use some softer materials to attenuate the higher frequency. So it's going to be, like I said, a multi-layer approach to try and reduce the noise. And what you also notice on a lot of those designs on YouTube is people are just arbitrarily installing fans to draw air from one side of the box through to the other with no real consideration as to how much airflow is required. Perhaps they're installing a fan that might have 100 CFM of air movement, and let's say the fan on the engine has 200 CFM of movement. Well, they might actually not be doing any good there. They could be potentially restricting some of the airflow depending on the size and the opening of that fan. It may have some additive effect, but it may not. So my design approach here is going to be a little different. I'm hoping to divide this whole box into two sections, if you will. So there will be a cool side, and that will basically be from the front side of the generator all the way up to the back. And there will be a divider in the box here, and then everything to that side is going to be the hot side. And the plan is that divider is going to have an opening that will seal against the back opening of the generator grill here. And the idea is that the generator fan itself on the engine will draw air through the generator unit itself, across the engine, across the exhaust, and then all of that exhaust heat and gas will be kept on the hot side of the engine. So only cool air is going to be on the engine side and on the electronic side itself. The hot side is going to just be for the exhaust gases that are going to get pushed out by that fan through an opening. The other plan here is to create an indirect path for the exhaust gases to travel. So what you do notice on a lot of other videos is a high amount or a high level of the sound noise that's coming from the generator is actually coming out of the exhaust. And when you have no impedance, nothing blocking that noise, the noises are going to travel out. So the plan here is to actually create a divider here, and then there will be a partial wall that will allow those gases to kind of snake. It'll go down and then around and then up and then out. So you'll not have any direct path for sound to travel, and that should help reduce a lot of the noise that you're hearing coming from the generator. So that's a little bit of a different approach that I'm going to take on this one. Okay, so there's a couple different things that we're going to need to do to build this hush box. Like I said, it's going to be a multiple layer approach here. The first layer is going to be the metal box. It's really not going to provide a lot of attenuation to the sound. As you can hear, naturally it rattles, it vibrates, and it's not going to provide real attenuation for low frequency. It may cut down on the extreme high frequency components, but the way the generator operates, there's not a lot of really high frequency noise coming from it. A lot of it is mid-range and low frequency, so that's where the multi-layer approach is really going to come through. The first step that I'm going to do here is to add some mass and rigidity to this box. So without getting too complex or crazy, you could use a variety of different materials. Now I happen to have a sheet of lightweight 1/2-inch drywall. Drywall is great for sound attenuation. It has good mass, it has good density, it doesn't have a lot of voids in it, and it's easy to work with. So the first step here is going to be to line the two longest sides, the bottom and the top, with some pieces of drywall, and that will help increase the overall mass of the box. The next layer after that is going to be the softer layer. We're going to use some Roxol foam board. That's like a spun rock wool insulation. It's rated for really high temperatures. It's actually fire rated, which is fantastic. We're going to line both the cold side and the hot side of the generator box with that to attenuate some of that noise. All right, a little change in my plan here. Before I go to install that drywall to increase the mass of the box, I'm going to start by installing the hot-cold divider here. This is going to be a pretty important piece. It's going to also help reinforce the box a little bit here. So by adding this, the sides will be less likely to resonate at certain frequencies. So the plan here is to have one divider, the hot-cold. It's going to have an opening cut in it that's going to mate directly to the exhaust vent on the generator. There will be another divider somewhere in the middle here, but it's not going to go the complete distance down. It's going to go maybe 2/3 the way down. And then the exhaust port is going to be at the top here, just to let the hot exhaust and engine air get out of there. And it'll basically be the same on the cool side. A little less space here just because we're only trying to draw cool air in. We're not trying to get all of that hot air out. Okay, I have the three dividers cut. The front one here, this is just indirect baffle, so the air intake is going to be low on this side, so anybody standing from the outside will not be able to directly see the engine. Means that basically you're not going to have any sound that will be coming from that opening. And then from the back here, the opening on the divider, hot-cold divider, will be right there, and this is another indirect baffle, so that when the exhaust port on the top side here is cut out, you will again have no direct path to see or to hear any of the noise that's coming out of the generator. Okay, so things are moving along here. I cut an additional piece of 1/2-inch Baltic birch that I'm going to use for the floor or the bottom of this box. And the reason I'm not just going to use drywall here is I want to be able to install maybe a strap or something that can hold the generator in place. Under load, it's going to vibrate and it's going to want to kind of move around a little bit. So the more plywood or whatever I can drill and kind of secure a strap to will work out better. It also gives me an opportunity to just pin this main divider into that bottom piece, and it'll help secure it a bit better. Unfortunately, I probably don't have enough room to get a nail gun in there and pin that in, but it'll still help hold it, a little bit of construction if you sit in there. Okay, so I've started to work on, I'm going to call it like a plenum that will connect the back grill of the generator to the exhaust hot side. And basically what I've come up with is just to use a couple 1-inch strips here, and more or less they frame in around this opening here, and with a little bit of neoprene or silicone gasket, it should make a tight seal so that no air is going to come back into the kind of engine bay of the box. Okay, so I'm running low on battery here with my phone. so I had to stop the time lapse. But basically, here's what I've come up with for the generator plenum. So it's just a little box, and that will mate right around the outside of the grill here. Sorry about that. And then what I did is I held that ring in place with the generator up against the divider here, and glued it, and then tacked it in with some brad nails. And then after that, I used the flush cut bit in the router to cut the opening out, and then I just put a quarter round on the outside here just to make it a little bit smoother. But basically that is actually, as you can see, kind of larger than the exhaust port on the generator. So that's going to direct all of the hot air, hot exhaust gases out into the hot side of the generator box. And all I need to do is basically just add a little bit of foam, oops, where are we here? A little bit of foam tape around the face of that plenum, and then it should seal up just perfectly against the generator. Alright, so I just did a quick test fit here in the box, and I've got the cold side baffle, I've got the hot and cold side divider, and I've got the generator pushed up against there so that fits nicely, and then here's the hot side baffle, and it's all coming together nice. I'm actually contemplating, rather than putting the exhaust port up high, I might put it on the bottom. Not quite sure what I've didn't decide on that yet, but overall it's looking pretty good. I offset the generator just to the back side a little bit, really for the reason that I need to be able to access the recoil starter, and that'll make it a little bit easier. So the next step now is to start getting these baffles secured into place so that they're not going to move, and get some of that drywall to start, and then after the drywall goes in, we'll get some of that rock salt board. Okay, so I cut out 2 openings, one at each end of this metal box. It's a pretty big opening. It's 3 inches by just under 9 inches, so it's got a pretty good opening size. Now that I've got that done, I'm going to start to mount the plywood base, and then the hot cold side divider, and then the 2 baffles after that. Okay, so I've got the bottom, the 2 baffles, and the divider all installed now. I just used PL Premium to glue everything in place. Before I got the bottom part glued in, I actually moved everything over, and I was able to nail this baffle into the bottom sheet here, and then I was also able to nail through here into the bottom piece. And so yeah, everything's set in place now. Gotta wait for the PL Premium to cure and hold everything there. So I'm going to try something different. I hoped to buy some, it's called Dynamat. It's a butyl membrane that's used for sound deadening, but there's something available locally in stores. It's called Blueskin, and it is another butyl type membrane. So I'm expecting that it might have similar properties to the Dynamat. So the plan here is to do maybe 1 layer of the Blueskin before I put the drywall in, and then maybe sandwich the drywall in between with another layer, and then the last kind of layer of this whole box will actually be some of the rock wool comfort board. So that'll provide that kind of softer material that's gonna absorb the higher frequencies coming from the generator. The idea is that the butyl membrane and the drywall and a little bit of this wood here are going to absorb some of the lower frequencies. So yeah, gonna get going with a little bit of that blueskin now. All right, well, it's gone from the black box to the blue box. I kind of underestimated exactly how much blueskin it would take to line all of the surfaces in this box. I thought it would maybe only take half of that roll, but in reality, I don't have a ton left, so probably not going to be able to do anything else in there. But it's making a difference in how this sounds. So previously, when it was just empty, it had more of a kind of a rattling sound, but now it's a lot less rattly, and it has a little bit more of a low frequency sound to it. So I think we're getting somewhere with all of this now. So the next step will be, I'm going to do some drywall on the side, and along the baffles and try and get that fitted. It is going to be a little bit tougher now that everything's kind of locked in place. So we'll see exactly what I can do. It doesn't have to be perfect. It just has to kind of line the inside as best as I can. Okay, so next step or layer here for the generator box was drywall and getting that installed. So everything around the perimeter is lined now. I didn't have enough to do the top, unfortunately, so hopefully we can just do without it. Worst case, I'll go and buy a sheet of 3/8 drywall, but it kind of sucks just to need about 12 inches of it. Otherwise, it has a much lower resonant frequency now. So once the PL Premium cures and all the drywall's fixed in place, the next step will be to start lining the box with the Roxol comfort board. Alright guys, well, here is the generator box in action. There is a 500 watt load on there right now, and the box is closed up as good as I can get it to close right now. We're looking at about 62, 63 dB. Now that's a slow response with an A weighting. If I change the weighting to a C weighting, that's going to measure a lot higher sound pressure level, because the C weighting measures lower on the audio spectrum, so it's going to account for a lot of that really low frequency, whereas the A weighting will roll that off. So it gives you an idea of how much low frequency noise is still being emitted by the generator. So what I'm going to do is I'm going to leave the meter on. I'm going to open up the cabinet, pull the generator up just so you get an idea of what the actual reduction of noise is by this box. so I changed the range into the 80 dB range, so we're looking at about 85 decibels at the C weighting. And about 80 decibels at the A weighting. Alright, so I'm going to readjust the meter here. The A weighting again, somewhere around 61, maybe 62. If I change the weighting to a C weighting, 76, 77 right now. So I'm just gonna disconnect the lamp. The generator's gonna go down to idle. So this is no load on the generator right now. We're looking at about 73 dB with the C weighting. On the A weighting, talking about 56 dB, 57. So it's a pretty dramatic difference actually. I could take the generator out and then you could get an idea of what the sound level is without a load on it, but really the difference in levels is the same whether it's in the box or out of the box. It's just there's an overall attenuation going on there. So anyway, yeah, I'm really happy with how this has worked out. It's doing what I wanted it to do. There is a nice flow of I'd say pretty warm air coming out of the exhaust, and on the intake side there's a nice cool breeze going in there. So that's exactly what you want. So a couple things that I still need to do to get this finished up. The first one is to get some gasket material around this opening here, and that's going to make sure that all of the air that's being drawn through the generator and being exhausted is actually not returning back into the cold side here, into the engine bay. And what I can tell right now is like pretty much everything in the engine bay is still cold to the touch, which is fantastic. All of the heat that we're looking at is basically at the back of the generator, right where it couples into that exhaust port and then on into the exhaust chamber. And yeah, so the next step, aside from doing a couple little finishing touches on the box, adding some different latches and stuff, I would like to do some testing just to be able to measure what the temperature within the engine case is outside, normal air, running with a load. Then we'll measure the same thing inside the box with the same load on there and just make sure that we are still operating in the same range. And then I'm also going to monitor the temperature in the exhaust side of the box there, just to make sure that it's not getting out of control either. I don't suspect it will, because there is good airflow going through here. It's going to remain relatively cool from what I'm thinking. But anyway, yeah, it's working out quite well. I'm pleased with how this is. So a couple more things to do, and we should be ready to go.